Section 6, first degree equations. These are often called linear equations because when you graph them, as we'll see in the next chapter, they form lines. So our first example is -4 a solution to each of the following equations. So to know if something is a solution, we just need to replace our variable with -4. So 3 times -4 plus 5, hopefully that is -7, which it in fact is. So this one is a solution. Now the second one, we'll replace x with -4, 2 times -4 minus 3, and that actually comes out to be -11. So that is not a solution. So -4 is a solution to part A, 3x plus 5 equals -7, but it's not a solution to 2x minus 3 equals 5. A solution makes the equation true. That's all we're after. Now, we have a couple of facts, okay, a couple of properties that we use to make our equation simpler. So, well, there are actually 4 of them here. But if A equals B, then A plus C equals B plus C, and A minus C equals B minus C. Effectively, you can add the same thing to both sides or subtract the same thing from both sides. Okay, next, if A equals B and C is not 0, this will not work for C being 0, then A times C equals B times C, and A divided by C equals B divided by C. Again, you can multiply by something on both sides or divide by something on both sides, okay, as long as it's not 0. Okay, let's move on to some example problems here. Solve each equation. 3p minus 5 equals 19. So first, we want to get the p by itself. So we are going to add 5 to both sides, because that will make it simpler because these two cancel out. So we get 3p equals 24. And then we can divide by 3 on both sides to get p equals 8. Now, as we did on that first example, I would highly recommend get into a habit of it now, taking this answer and plugging it back into making sure that is a true statement. So that's 3 times 8, 24, minus 5 is 19. This is a true statement. Okay, so that checks out. All right, part B, we will subtract 3 from both sides. Okay, giving us 4y equals -8. Dividing by 4, we come out with y equals -2. So if I plug -2 in here, that's -8 plus 3, which is -5. Okay. Last of these simplistic equations, -2k plus 6 equals 2. First, we will subtract 6 from both sides, so we get -2k equals -4. And then dividing by -2 on both sides, we get k equals +2. If we plug 2 in, so that's -4 plus 6, that is in fact +2. Okay, so those are what you might call two-step equations. Okay, so starting with our next example, we will have quite a few that are multi-step. Okay, solve each equation. All right, so the first thing we're going to have to do is actually distribute and combine like terms. Okay, so this is we're going to have a 3m here and a 2m here, so we should get 5m. Okay, this side's not going to change. Now here we get -18 plus 8, that is -10. Okay, equals 4m minus 2. I'm probably not showing as much work as would be wise to do. All right, so now we're going to move our variables to one side. So I'm going to subtract 4m from both sides. All right, I'm going to go ahead and do this in one step. Add 10 to both sides. All right, so we get m equals, cancels, and +8. Now here's where it really would be smart to start doing that, to checking. So that's 3 times 2. That's 6, plus 2 times 12, well, that's 24, so that's 30. 8 up here, that's 32, minus 2, which is 30. So it does check out. Now let me see if I can show a little more work on part B. Distributing, we get -2y minus 6. Bring down the 4y. Over here we have 3y plus 3 minus 6. So combining like terms here, we get 2y minus 6, and that's 3y minus 3. All right, so subtracting 2y from both sides, we get y minus 3 on the right equals negative 6. Adding 3 to both sides gets us y equals negative 3. Okay, so that would be 0 right there. So it would be negative 12 on one side. And that would be negative 2, negative 6, negative 12. Okay, so this actually does check out. So the answer to B is y equals negative 3. Okay, starting with part C, you're going to have to deal with some fractions. So we have r divided by 10 minus 2 over 15 equals 3r over 20 minus 1/5. Okay, now the smartest thing we can actually do right here is actually to cancel out our denominators. Okay, to get rid of that denominator. Okay, so we're going to have to find the least common denominator, or the least common multiple of 10, 15, 20, and 5. Now, I happen to know offhand that that is going to be something like 60. 60 is a multiple of 10, of 15, of 20, and of 5. So I'm going to multiply everything by 60. Okay, so what that's going to look like is 60 times r over 10 minus 60 times 2 over 15 equals 60 times 3r over 20 minus 60 times 1/5. Now, clearly, a lot of these are going to reduce. In fact, all of them are going to reduce. That was actually the point of using 60. So this turns into 6r. That's 4, so minus 8. That's 3, so 9r. And that's 12, so minus 12. So it reduces down to one of our multi-step equations. So we need to get our variables on one side. So I'm going to subtract 6r, which will give us 3r. Okay, subtract 6r. Now add 12 to both sides. That's going to be positive 4. So dividing by 3, r equals 4/3. And again, plug this back in. But if you notice, anywhere you plug in 3/4, there are going to be no problems like having a 0 in the denominator, or having a square root of a negative, or anything like that. Nothing's really going to majorly go wrong. Okay, so all you have to do is just make sure that checks out. Now, I've already done that, so I'm not going to do that at this point. But part D, we are going to check no matter what. So, to find the least common denominator here, well, 3 is in all of them, and so is k plus 2. So we're going to multiply by 3k plus 2. Okay, now hopefully you can notice that the k plus 2 is going to cancel in both of these, and so is the 3. So this actually leaves the 4 minus k. Then over here, the 3 cancels out, so we're left with 5 times k plus 2. All right, so that's 5k plus 10, and 4 minus k. So that should leave us with, if we move things around, adding that we get 6k. Subtracting 10, we get negative 6. So k should be negative 1. Okay, k equals negative 1. All right, so let's plug that in and make sure nothing goes wrong. So if I plug negative 1 in here, this turns into 4/3. Okay, right here it's minus a negative 1, so plus 1 over 3 equals 5/3. And in fact, that is a true statement back from elementary school. So we know that this works out. Okay, part D, or part E, rather. 3x minus 4 over x minus 2 equals x over x minus 2. In this case, the least common denominator is x minus 2. And I'm going to put that in parentheses. It's a quantity. That's going to cancel on both sides. So we get 3x minus 4 equals x. Moving some things around, we get 2x equals 4, or x equals 2. Okay, great. X equals 2. Problem here. We need to make sure we check it every time, especially when you have fractions in them. Okay, fractions, square roots, things like that. So if we take the 2, x equals 2, replace it everywhere we see an X appear. You may see a problem real quickly. 2 minus 2 is 0. You're dividing by 0 in both cases. So this is our only possible solution. It's not a solution. That means the answer is no solution. And there we have it. It is no solution. Okay, the last equation that we have right here before we get to our word problems, we actually have many variables here. We have to be told which one to solve for. So in this case, we are going to solve for x. We're solving for x. So we need to get the terms of the x all on one side. First thing we're going to do, though, is distribute this right here. 32 minus 8x plus 6p equals negative 5k minus 11yx. Okay, now as I said, we need to get the terms with the x on one side. That would be the 8x term right here, minus 8x, and that would be the minus 11yx. Okay, so we need to get those on one side. So I'm going to actually add 8x to both sides. Add 8x. So that will give us, over here, we're going to have minus 11yx plus 8x. That'd be the easiest thing to do. Now, if we add 5k to the other side, we should have 32 plus 6p plus 5k. Okay, now this doesn't seem like we're a whole lot closer, but if you actually notice, we can actually factor out an x here. This is x times negative 11y plus 8. Okay? So that means if we take this quantity over here, this set of stuff, and we divide by this, negative 11y plus 8, divide by negative 11y plus 8, that is our value for x. X equals 32 plus 6p plus 5k, all divided by negative 11, and I'm going to rearrange it actually. It might be more acceptable to say 8 minus 11y. Okay, so now we solve for that in terms of x. Okay, now we have a couple of word problems to look at, and then this section will be finished. Example 4. An investor owns two pieces of property. One, worth twice as much as the other, returns 6% in annual interest, while the other returns 4%. Find the value of each piece of property if the total annual interest earned is $8,000. So we have a total amount of interest. One of them returns 4%, one returns 6%. And we also know that one of them is worth twice as much as the other. Okay? So first, I'm going to try to make a table. We have two properties, right? We have property 1 and we have property 2. All right? And I'm going to put our interest down here. And just our properties. All right, so first off, the first property, I'm just going to call it x. I don't know how much it is. Okay, but one of them is worth twice as much, so that would be 2x over here. All right, now on the interest plane here, we've got the interest is 6% for one of them. Well, it says the one that's worth twice as much is 6%, so that's 0.06%, 0.06, no percent, and the other is 0.04, or 4% interest. Okay, so that means that the interest gained from property 1 is 0.04x, and the interest gained from property 2 is 0.06 times 2x. And the grand total is 8,000. So now we have an equation we can solve. Okay, so if we actually multiply these together, we should get a total of 0.12 right here, and 0.04, so 0.16. 0.16x equals 8,000. Dividing by 0.16, I'm going to go ahead and put my 0 out here. Okay, x is $50,000. $50,000. So that actually tells us how much property 1 is. Property 2, so this is property 1, property 2 is 2x. So it is 100,000. Okay. So $100,000 for that second property. Now, it would be really smart to check this. Okay, to take $50,000 with what is it, 4% interest, and $100,000 with 6% interest, and see if you do get a grand total of $8,000, which you should. Okay, our next problem, example 5. In 2012, Time Magazine reported that Spotify acquired in 7 business quarters the same amount of users, number of users, as Rhapsody acquired in 11 years. That's fast. Spotify's average rate of user acquisition per quarter was 120,000 more than Rhapsody's average rate per quarter. Find the average rate of user acquisition per quarter for each company. Okay, so let's see if we can organize this sum. We have Rhapsody, we have Spotify. Alright, now what do we care about with these two companies? Well, first, we care about the number of quarters. Okay, and quarters in this case are quarters of a year. Okay, so Rhapsody, it took them 11 years with them. So how many quarters is that? Well, there are 4 quarters in a year, so it's 44 quarters. Spotify is 7 business quarters. Next thing we care about is we want to find the rate, find the average rate. So in this case, we don't know this. So we know that Rhapsody, well, one of these is going to be X. Okay, so let's see which one was. What do we know about them? Spotify's average rate of user acquisition per quarter was 120,000 more than Rhapsody's. So we're going to use X for Rhapsody and 120,000 plus X for Spotify, since theirs was 120,000 more. And then the last thing we care about is actually the number of users, because they tell us when they are the same number of users. So the number of users. So in this case, this is going to be 44x. Okay, because it's 44 quarters at X per quarter. And then Spotify is 7 times 120,000 plus X, because it's 7 quarters at this rate. And we want to know when they are the same. So 44x equals, and let's see, that's going to be 840,000 plus 7x. All right, so if we rearrange, we should get 37x equals 840,000. Or x equals approximately, shouldn't put the equal sign there, x is approximately 22,703, and that's Rhapsody users per quarter. Per quarter. Okay, so that's Rhapsody users because Rhapsody is X. So that actually doesn't answer our question totally. There's our Rhapsody users. Rhapsody users per quarter. And so that tells us that the Spotify users per quarter, should be somewhere in the neighborhood of 142,000. 142,702 Spotify users per quarter. And so there are the rates that we were asked for. Find the average rate of user acquisition per quarter. So there we have it. Okay. All right, last problem of this type. An oil company needs to fill orders for an 89 octane gas, but has only 87 and 93 octane gas on hand. The octane rating is the percentage of isooctane in the standard fuel. How much of each type should be mixed together to produce 100,000 gallons of 89 octane gas? Okay, so far we can see there's 3 types of gasoline. So let's actually start from there. We have our type. That's 87, 93, and we're mixing that to make 89. Okay, now how much of each of these do we have? Okay, so we don't know actually how much 87 octane. Let's use X for that. We don't straight away know how much 93 we have, but we do know that they are together to produce 100,000. So it's how many are left over? 100,000 minus X. Now we do know how much we want of 89 octane gasoline. It's 100,000 gallons. Okay. Now another thing we know is that this type right here, the octane level, tells us how much of that chemical there is, isooctane. There's 87%, 93%, and 89%. All I'm doing so far is seeing if I can organize this some way. Okay, and then next we can actually use this to figure out how much isooctane there is. In this case, there's 0.87x. In this one, there's 0.93 times 100,000 minus x. Okay, and in this case, there is 0.89 times 100,000. And we want these two to be the same. So what we have to do is take 0.87x plus 0.93 times 100,000 minus x. I don't need that parenthesis yet. And we want to know when that's equal to 0.89 times 100,000. Okay. Now, if we rearrange some things, actually I'm just going to jump straight to the answer. Okay, this is for you to do on your own. It should come out to be approximately 66,667 gallons for X. So that is that many gallons of 87 octane. Okay, now since they total to be 100,000 gallons, that means that we should have 33,333 gallons of 93 octane. Okay, now I'm going to leave this to you also to verify how much octane there actually is. Okay, multiply this by 0.87, this by 93, and see if you actually get 89 like you expect. All right, that is the end of this section on first-degree equations, and this topic is going to come up repeatedly, so we need to make sure we get this down.